Hello, I'm Randy Case. I'm an architect and I'm a member of the Michigan Architectural Foundation. Did you know studies show that thought processes that nurture creativity and critical thinking begin at a young age and they grow over a lifetime? And that this influences how children learn and look at the world around them. Fostering those thought processes in a fun, engaging, and interactive way is the premise on which the Michigan Architectural Foundation's Architecture It's Elementary is based. Architecture It's Elementary is a free educational curriculum program developed by Michigan Architectural Foundation that introduces kindergarten through 5th grade students to the architecture and the built environment. Architecture It's Elementary also has been designed to help kids learn and understand order and think visually and problem solve in functional ways. And of course, to make them more aware of the role architecture plays in their lives. Architecture It's Elementary consists of hands-on, engaging group and individual classroom lessons and activities that encompass principles of MAF, science, social studies, art, language arts, and history. The web-based guidebook includes 10 lesson plans for each elementary school year from kindergarten. It goes through the 5th grade. Each of the lessons has been created to align with the Michigan Educational Program standards. Lessons can easily be adapted to meet the needs and interests of each classroom school. The program also can be used in homeschooling programs and by parents who want to engage students at home in activity and interactive and creative learning experiences with their children. The lesson plan activities spark imagination and creativity and stimulate observation and reasoning and critical thinking skills that benefit children over a lifetime. For example, the kindergarten lesson introduces the basic two-dimensional shapes and asks the students to find and label examples of the shapes in their classrooms and in their houses. The 3rd grade lesson plan culminates with lessons where students begin to design a house. The 5th grade lesson teaches kids about characteristics that differentiate cities and activities where they design a city. This is Allison Cosgrove.
Hello and welcome to my classroom. I teach 2nd grade at Voyager Elementary School here in Howell. Today my students are going to participate in some of the 2nd grade lessons from Architecture It's Elementary. We're going to be learning about structural concepts and how to measure and draw our classroom and the objects that are in it. Friends, today we're going to be talking about measurement. We've been working on measuring in science, and I want you to think about some things right now. What are some things that you know? I want you to raise your hand. What do you know about measuring, about measurement? Yes?
That sometimes you can use a yardstick.
So you can use a yardstick. Awesome. What is something else that we know about measuring? Brianna?
You can use cubes.
Oh, I love that you said cubes. And do you know when we use cubes, what kind of units do we say we're measuring in? Standard or
Non-standard.
what is that?
Non-standard.
Non-standard. Yes.
A
So
ruler.
A ruler. We use rulers. And when we use rulers, friends, what kinds of units do we use when we record our measuring with rulers? Whisper to a neighbor. I heard someone. Centimeters. I heard it. So centimeters. What's another unit that we use when we're measuring with rulers? Parker.
Normally we use rulers. We use inches.
You use inches. Awesome. Would you kiss your brain for me, please? Inches. Who's got something else that they can tell me about measuring? What do you know about measuring? Finn?
Tape measure.
Oh my gosh, we use tape measures too. Tape measures, they kind of stretch out, don't they?
Yeah, and they also bend. So
They-
no matter what.
They also bend, don't they? Who's got one more thing that they want to share about your schema, your knowledge? What do you know about measurement?
We can use multiple yardsticks.
And when would you use multiple yardsticks?
When you're like measuring like trucks, cars, real cars.
And then you have to put those tools kind of what?
Together.
End to end. Good job, kiss your brain. What's a question that you have about measuring? What's something that we want to know before we get started on our fun lesson today? What do you want to know? What do you want to know, Josh?
How far it will go.
So you want to know how far, tell me more.
It will go.
What's it? How far will,
The car go.
oh, like distance. You're thinking about measuring distance. How far will the toy car go in distance? Think about, though, in the room today, we're going to be measuring objects. I didn't tell you what our learning target is. We're going to be able today to measure objects around the room. I didn't tell you that. So we're going to be able to measure objects around the room. So I want to ask you today, what are some questions that you want to know when we measure our objects around the room? What do you want to know today?
How long does it go?
Tell me more about that.
How long does the car go?
Let's not think about cars. Let's look up there. We're going to be measuring these objects today. We're going to be measuring, if you look up on the board, read it with me, the pink word. We're going to measure a what? Table, a bookshelf. Read me the next one.
An easel.
The easel. What's the next one?
The file
File cabinet. And then
Rug.
When we read the book called How Big is a Foot, and it was about the king and the queen, right? Oh my gosh, you just took that right out of my brain today. So we're going to compare this to this. Now, if we actually used my foot and we used your foot, Emma, are our feet the same size? Hold it up. Do we have the same size foot? Well, I have big shoes on, don't I? But not really, right? So I couldn't really measure accurately if I used my shoe and her shoe. That wouldn't be the same, right? But everybody in here today, friends, you're going to get a paper foot. And what do you notice my paper foot measures? What do you notice, Parker?
12 inches.
12 inches. And friends, how many inches are there in one foot?
12.
12 inches in a foot. So here's what we're going to do. You're going to take this. I'm going to give you 2 minutes. And when I say class, class, you'll say?
Yes,
And
yes.
you're going to come back to the carpet. And you're going to be ready to share one object that you measured that was not more than 1 foot.
I need to check scissors. You got a white one. I mean, a cut of paper. You got white. Okay, so.
Class,
Yes.
meet me on the carpet. I want someone to tell me, what did you find in the room that was about 1 foot? What did you find? Finn?
A bag of chips.
A bag of chips. Would you go get that bag of chips, please, so that you can prove? I need some evidence. Can you show me that that's about 1 foot? And let's see, who else wants to share something that you found that was about 1 foot? Parker.
Crock pot.
Oh, the crock pot. You can't bring that over here because that's hot. Let's see. Finn, come up here and let's try it. I'll hold the bag of chips and let's measure. Let's see if Finn's about right. Is this about 1 foot, friends?
It's the same.
All right, let's give him an affirmation on property. 1, 2, 3. Good job, thank you. I'm only going to give you about 5 minutes, and I want you to work together as a team with your paper foot. Your 12 inches equals 1 foot. And you're going to get ready, and on your paper, it's just like mine, you're going to record, you're going to record in feet and in inches. But I have a question. What's going to happen? Lillian, will you come up and help Mrs. Cosgrove for a minute?
No.
If I were to measure the whiteboard ledge, I need to start measuring from the start to the what? From the beginning to the end. These have to match up. They have to touch each other. So I'm going to take the paper foot, and it's got to touch. So right there, how many feet does that show us this ledge is so far? 2. So you're going to write down the objects that I wrote for you, and you're going to work together. And how many objects am I asking you to measure today? Show me on your fingers. 2.
Do you want to do more?
Deciding together what objects it is that they want to measure. Remember, you're choosing 2. If you have any marks left over, you record those as inches.
So let's do that.
So let's go back and double check that.
Wait. Do we all have one or just this Parker? Is Parker like the only one who? Feet is 2 feet.
And we want to say how many inches?
10 and 2.
9 feet, and then 1, 2,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
so that would be 9 feet
and
10
10
inches. Good job. Nice job. What did we notice about the length of the rug? What did we notice, friends, about the length of the rug? Did it take all of your measuring?
Yes.
Or was it in all feet, or did you have to record some inches?
We had to record something.
So I saw Parker's group, they did 9 feet, and it was how many inches?
10.
10 inches. Did you know if you were to write 9 feet, 10 inches, here's what it would look like, friends? Watch me. This is 9 feet, that little mark, 10 inches. All right, I'm going to turn on our projector. What's a structure, Zoe?
A structure is something like that. You can make stuff into it, and like you can make it like what you can make it like this.
Holds things up. It's called gravity. Have you heard that
Oh,
word?
yeah.
Yeah. Have you heard that word gravity before?
Yeah.
So,
Yeah, that's what keeps
so
it
there's a pull of gravity. So my forearm is actually kind of like a column. A column. It looks like a column, something that goes up and down. And the book is actually the beam of this structure. Okay? So what kinds of things, what holds these things in place? I want you to think about that. What holds these types of things in place? Well, it's the weight. Do you notice how the weight of the book, it's transferred to what?
Your arm.
My arm. It's transferred to my hand, isn't it? And then where's the weight of my forearm transferred to?
The chair.
The stool. That's exactly right. So I want you to take a look at this, and I want you to think about these structures up here. And what does that say that this structure is? What is that? What's it called, everybody? Suspension bridge. What do we know bridges are used for? What are bridges used for, Lillian?
To go over the water so cars could go to different places.
Yes, and so that bridge had to be built in a safe way so that it could hold the weight of the cars up, right?
Yeah.
Right? So I want you to be thinking, I'm going to show you a few more pictures. I want you to look at some of these structures and take a look at this. What do you see right here, friends?
It's an arch.
An arch. Who can give me an example of a real life arch that you've seen somewhere in our world?
You know the Renaissance Festival? I've seen one there when you go in.
Excellent. What I'm going to have you guys do is we're going to practice making some of these. So I want to know if I have a friend. I'm going to show you one more piece. Do I have a couple volunteers that could come up and show me how we would make an arch? Using your body, how would we make an arch? How about Zoe and Sophia? Let's see. Let's watch them, friends. Let's look to see how are they going to make an arch with their body. Ooh, good. All right, good. Who can show me a dome? I'm going to pick a few friends. Ben, stand up. You're going to use your bodies together and you're going to create a dome. Parker? Parker? Lillian, come make a dome. Show me a dome right there behind you. Oh, look at you. Your group. How about you four come over here and make a dome? You four and you three stand up. Let's make a dome. Let's see if you can make a dome. Dome. Aiden, jump in. Awesome. All right, pick a partner. Nice job, friends. Look at your dome. Now, I want you to stand 2 by 2, class.
Yes, yes.
Class.
Yes,
I want you.
No, we have to round
Show me with class.
No, we have to round it.
Show me with your body how you would make a column and a beam. I want you to stand 2 by 2, and I want to see you make a column and a beam. Columns are these structural pieces that go up and down, and the beam is what goes across. It's holding. Remember, like I did the book in my forearm.
No, you put both your hands up there.
No, straight like that.
Show me.
No, do put both your hands up.
That would be good.
Strike a pose. I'm going to do one with Sophia. This is kind of what I'm thinking. Like if we were to put our, everyone sit on the carpet for a minute. 3, 2, 1. Could you put your arm out? Let's see what we've got. Let's see. I'm a little bit taller than her. If we're a column and a beam, let's see if we can hold this. Is our structure. holding
The book.
the book. Say hello to my friend, Mr. Dan Bowman.
You can use this device to measure, I can measure the room, for instance. So
Wait,
I'm going to turn it
Dan?
on. Yes. I'm going to turn it on,
Can I touch the
and I'm going to push this button. And if you look on the back wall, you can see a little red dot. Watch. Do you see it? See that red dot? Now when I push the button again, it clicks. 8 inches.
29 feet and 6 inches.
29 feet 6 inches from the front of the classroom to the back. Do you want to help me do the room from side to side? Push the button.
That's fine.
Do we see the laser?
Yeah,
Push the button again now. It says 3 and 13/16 inches. That's a part of an inch.
Inches.
Right? So we'll just say 26 feet 3 inches. Great job.
Good job, Parker. High five. So you mean there's other ways to measure things besides just using rulers and tape measures and yardsticks?
Absolutely.
So, friends, what kind of a question do you have for Mr. Bowman that he might need to use that device for? What might he need to measure something with that? Who has a question for him? I'm looking for friends that are sitting flat on their bottoms.
Yes?
Can you measure from down to up?
Sure can. Do you want to try doing it? I'll turn it on and you can do
Great
that.
question,
All
Parker.
right, you're going to push this button. Go ahead and make sure you move your... All right, do you see the red dot? Okay, push the button again. All right, you heard it click, and you can read that.
8 feet 8 inches.
8 feet 8 inches.
So
That's
from the floor to the ceiling, that's 8 feet 8 inches. Let's look at how tall Mr. Bowman is.
How would we do that?
Does he look like he's 8 feet 8 inches?
Oh, I see.
Nope, he's not. So we would have to try to figure out the distance between the top of his head to the top of the ceiling, right? What a cool tool, Mr. Bowman.
I really like it, and it's very helpful. Very handy.
Very cool. Thank you. What do we say to him for sharing that?
Thank you.
That's a cool tool. That's a very cool tool.
The Michigan Architectural Foundation is a nonprofit organization dedicated to advancing awareness of how architecture enriches our lives. In addition to Architecture It's Elementary, MAF provides and supports programming that educates and inspires a future generation of architectural advocates of all ages. You can find out more about MAF and our programs at the MichiganArchitecturalFoundation.org.